So what are we going to be doing today? First off, we got some housekeeping. I'm going to cover Kubernetes basics, and then we're going to go over Kubernetes operators. We got some stuff on the Cassandra operator. And then, of course, nothing is good without monitoring, so we're going to actually cover some dashboard, Grafana, Prometheus monitoring, and then kind of wrap up at the end with some additional resources you can all utilize. So should be good here. All right, so housekeeping and quiz. This particular session, we're not going to go deep into what is Cassandra, how does it work, how do we data model, how do we be awesome with it. We're trying to talk more about the Cassandra operator in Kubernetes. What that means is we're talking about Kubernetes.
Yeah. Yeah, no much stuff on Cassandra today. Is really we are running Cassandra inside Kubernetes.
Absolutely. And if you are curious about Cassandra and you want to learn about Cassandra content and all of the other things, feel free to come on by pretty much any other week. We talk about it all the time. So, stick around for this, even if you were hoping for a lot of Cassandra stuff. I'm sure you'll get something cool out of this, but please do come back. We always love to educate and enable as much as we can.
Sure.
All right. So for today, we got a couple things here. Of course, we got the stream. That's what you're watching right now. At least, hopefully, you are. If you're not, I don't know how you're hearing this, so getting a little meta there. You got your laptop. We're going to be doing some labs, and for that, you will need a laptop. We'll get into some more details there, but just have one handy. Questions, there's the Discord link. It's been posted, I believe, in the YouTube, and it should be posted momentarily in Twitch chat. Basically, join that Discord. There's a few rooms. There's the main session there. You can just go ahead and type questions there. We have a lot of DataStax folks on the line here who are basically there to answer questions, handle issues, make sure things run smoothly, and that you get a good experience here.
Yeah, that's very important. There are people helping us answering questions on chat and on Discord. So yeah, you take your time and ask any question. That's totally fine.
Lastly, we've got a GitHub with all the materials, which I believe we are sending links out to momentarily, so you guys should all see those. Basically, anything you do here today, we want you to be able to take home and play with and do again, or just explore. So the GitHubs are, for all of our sessions that we do, are available to you guys. I strongly encourage you taking advantage of those and check them out. Learn something new and maybe even take them and make them better. So we always take suggestions. We're going to dive right in. Kubernetes basics. So what is this whole container versus virtual machine? Like, what are these things actually? Well, it's actually pretty cool. So virtual machines are basically a guest OS that runs on a host. So it's, if I had, say, VirtualBox or maybe something from VMware, I could actually host a different OS that I'm running on my whatever system I've got as the base OS. I could host something completely different. So I could run Red Hat on my Windows box or whatever. And that's kind of a container. It looks like a container. But the difference between a virtual machine and a container like a Docker container, for example, is that it doesn't have its own OS. It actually uses the host operating system, but then sets up its own container to run inside. So it's kind of a way to stretch your resources a little farther, because now instead of all the overhead to actually run that OS for each of those buckets that you're running your apps in, you can just use the operating system of the base server. So it's really, really a powerful tool to extend your resources a little bit further. All right. So Docker. What is Docker? What does it look like? Well, basically, Docker is a process. This means there is Docker D. It is a daemon. I mean, that's at its core, it is a running process. There's a REST API that wraps around that, which allows for interaction from clients. And the clients are how we, as the operators, interact with the REST API. Pretty simple, nothing too crazy there. But the cool thing is that this is where we'll actually start to use a CLI to provision containers very, very quickly and very efficiently in, well, as you'll see in a moment with Kubernetes in a distributed environment. So very, very cool. Data volumes connect to these individual containers. You've got your own networking that basically you configure. And again, we'll take a look at some of these as we progress throughout the information here. But just for now, keep this picture in your head. This is basically what we're going to go through.
Yep.
Okay. So architecture. We got that client. If you remember, I said in the last slide, that's basically how we are interacting. So we are actually issuing CLI commands. So the Docker build, Docker pull, Docker run, we're typing those into our CLI, hitting enter. Those commands are going to the Docker host. The Docker host is basically the thing that holds all your containers. Now, containers are the individual running processes. They're the self-contained, you can almost call them sandboxed in a way, processes. And they are using images to create the correct containers. An image is basically like a template in some ways. Think of it like a recipe. The image is the pre-compiled recipe for how that container is going to be built. So dependencies, services that you needed, ports that you wanted open, however you wanted that particular container configured, you set that up in an image, and then you can use that image to build a container. Pretty simple. And then, yeah, that's kind of the basic concept here.
Yeah.
Anything I've missed here,
No,
Cedric?
I think you're good. I think you're good.
Awesome. All right. So how do we actually, what do these commands look like? Well, they get to be pretty complex pretty quickly. You'll see down here the Docker run command I've got. We're just starting a Cassandra Docker container.
Mm-hmm.
Now, that's not, on one hand, a very complex process. It's really, we're just starting a single process, and we're opening a couple ports. You'll notice we got our port declarations down there, the 7000 and the 9042. We've got an address that we're specifying as the broadcast address. Nothing that crazy, but that's still a lot of typing for a single command to have in a command line. It can get kind of obnoxious pretty quickly. Running Cassandra, also, if you know much about Cassandra, you generally don't have just a single node either. So that's another point we'll get into in just a moment. But Docker run, if you're actually setting things up from the command line, is basically how you set up these containers. That's where Docker Compose comes in. Now, Docker Compose is actually really nifty because we can take everything that whole command laid out, and we can put it into a YAML file, and then run our container, or set up our container based on that YAML file. And so you see we got our port declarations there. We have all the things we need to specify to actually set up the container correctly the way we wanted it to. Now, for those of you who are a little more Cassandra experts here, you'll notice this particular container is named Cassandra seed node. This is for a particular kind of node in Cassandra. So we would actually need a different one, a different YAML file if we were setting up a non-seed node. So there's still some thought we have to give to this, but this is a lot easier than having to type out a huge 7-line command every time I want to provision something.
Yeah.
I simply reference the YAML, we're good to go.
Yeah, and so indeed, you don't have to provide everything in the command line, but still, we need to have something special for the seed and something special for the Cassandra node. Look at the command. We need to wait that the seed has been started to be able to start the node. And this is one of the rules in Cassandra. You cannot start everything at the same time. And so later on, when we dig into Kubernetes, at some point we need to tell Kubernetes, no, if a Cassandra node goes down, please don't restart it immediately. There are some rules to respect. Okay. Yeah.
Yes.
That's
actually a good point. We'll dive into that more in a slide or two here. But honestly, there was a long time where Cassandra and Kubernetes, people were saying, don't use them together. They don't fit. And part of it's because of the self-healing that Kubernetes does is actually bad when
Yes.
Cassandra is trying to handle its own, and it clashed. But there are ways to make that better, and we'll get into a couple of those
All
here.
right.
Okay. So Docker Compose, not really production ready. It's good for dev. It's actually fantastic for dev. I've used it a number of times in dev. But it's only on a single box, and it's not something where I can take 50 servers and have this shared resource pool and go out and deploy something. I would never really do that. That's where Kubernetes comes in. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. That basically means it is that one-stop shop where I can take all of the operations stuff that I'd have to deal with in the day-to-day, and I can do it through Kubernetes over a wide range of hardware. So really, really cool. So what does Kubernetes actually look like? Well, some of the features, I'm not going to go over all of these, but a couple of them that are really, really interesting. Automated rollouts and rollbacks. So if you have an app, for example, that needs to be taken offline and then updated and then brought back up, you can actually do a number of things with Kubernetes so that your application from the user's perspective was never brought down. Whether it's provisioning new instances that are now the updated version and then just spinning down your old ones, or a wide variety of other things. There are a lot of tools you have at your disposal to make your operations really, really smooth. Horizontal scaling. Cassandra people in the room are going, yeah!
Of course.
Horizontal scaling is awesome. We love horizontal scaling because it gets rid of a lot of the limitations that vertical scaling have, especially around things like your wallet. um, so horizontal scaling is really, really cool, and literally, you want more instances of a particular container in Kubernetes, you can add more resources and then deploy them. It's really that simple. Um, Another really, really cool one is the service discovery and load balancing. Now, services, it's kind of it's the only place I'm aware of that calls what they call services. Everywhere else, I would know them as like network connections or something along those lines. They aren't actually a service like you'd think of from a Linux perspective. It's literally just how your Kubernetes cluster knows about different things. So if you have an HTTP, a web service, it would be registered as a web service. And then when a particular piece of your application goes, hey, where's the web service? It handles all the routing for you. It does that all automatically without you having to sit there and map it out and draw it out. Really, really, really cool. So
Yeah, that's very cool. So I just interrupt you 1 second.
yeah.
People asking for, are starting to ask, what do I need to install and stuff like that for my exercise.
Yes.
So, we saw in the survey at the beginning, we do have Linux box ready for you. So please ask link to folks on Discord, or if you need to install on your laptop, in the GitHub repo, I shared the link. It's very step by step. But don't worry, exercise number 0 is really make you ready to do the exercise. Okay, we can go.
Awesome. All right. There we go. All right. So let's talk some infrastructure here. We have this term called a cluster. What is a Kubernetes cluster? Very similar to Cassandra clusters. That is basically your entire single setup of Kubernetes. So all of the things that you have in your deployment that are governed by Kubernetes, that makes up your cluster. We got our master. The master basically is what controls the whole thing. It's how you actually interact. That's where your REST API is actually talking to the master, which then goes out and delegates the tasks. Then you got your nodes. Nodes are literally just what you think they are. They are the workers. They, say I have this many resources. The master says I got this job. It's going to take this, this many resources. Here you go. This container goes on this particular node, and that interaction there is all handled automatically. That's not something you really need to do. Now we're going to be using, I believe, kubectl is the particular one today. Really, really good. Isn't there another one called? Is it Minikube as
Um,
well?
yeah, so kubectl is really just a client, interacting
Mm.
with the kube installation, and you can install Kubernetes in many, software. Kind is one of them. Minikube is one
Ah,
of them, and you do have all the distribution available in the cloud provider. kubectl is really just a client interacting with the API.
right. Okay. Yeah. All right. So Kubernetes control plane. So the master, right? The master actually uses etcd. If any of you guys have used etcd, this is exactly what you think it is. It's the key value store, and that's basically how it keeps track of everything. That's its back-end store. It's got the controller manager, and it's got the scheduler. The scheduler, of course, is what takes the particular pod and puts it on a specific node. And you'll understand a little more of the those terms in a minute here in my next slide, actually. And then, of course, the API server, REST API, that all comes together basically to create the master. And you'll see we got all the nodes down there right below that, and we'll talk about those right here. So kubelet is the primary node agent. Each node, in order to be a Kubernetes participant, needs to have the kubelet. Sorry, that's really hard to say, actually.
Kubelet, yeah.
I never say it out loud. I read it, but never say it. So that's basically what says it. You just like in Cassandra, how you need to have an install of Cassandra on the box. This would be essentially equivalent. The kube proxy is the network proxy that runs on each node. This is what, oh, you remember I mentioned that services discovery that Kubernetes takes care of for you? This is what handles a lot of that. A lot of the logic for all this just magically talking to what it needs to talk to is at that layer. Um, really, really cool. And now pods are actually really nifty. Pods are collections of containers that can run on a host. Now, it can be one or it could be many. There's a single instance of something running inside a pod is just as valid as running 50 instances of something. Like, again, if I had a website and I wanted to do some load balancing or distribute the load over a lot of different hardware, I could put, say, 50 instances of this website, of the actual web server, into a pod and deploy that. So pretty nifty.
Yeah. I do have
Okay.
a question on the chat here about master and worker. So as far as I know, you will install a machine to be a Kubernetes master, and you can scale out masters and have high availability for Kubernetes. And there are workers, and you can scale out workers. But it's not one of the workers that is elected to become a master, because as you can see, those are not running the same process at all.
Right. Right. It's a completely different process. Absolutely. All right. Namespaces. This is where it gets good. So if you think about an app, and especially something with like microservice architecture, right? You've got a lot of different moving parts, and you maybe have each of them containerized in a different container. So you have, say, your database, you have your web server, you have some middle layer, maybe some other analytics stuff you've got going on the side. These are all part of your app as a whole. When you deploy your website or you deploy your app, you need all of these things to be up and running. Well, this is where namespaces come in. So namespace is basically the logical, it isn't a physical barrier, but it's basically a bucket that we can put all those different pieces in that make up our thing. So in the case of Cassandra, when we're building out something around Cassandra, we're going to use the Cass operator namespace. If we had, again, a web app, we could name it whatever we want. There are a bunch of default namespaces I'd like to point out as well. Kube system, of course, being one of those. That's used for basically internal Kubernetes things, the Kubernetes doing Kubernetes. And then default, of course, being the, default. All right. So namespaces provide basically scopes for names, same as any programming language you've probably used. It's basically just a way to say this all belongs together. All right. Storage. This is one of the really interesting things about Cassandra and Kubernetes. By default, most things in Kubernetes are pretty much ephemeral. They go away, they go up and down, and it doesn't care if they survive. When you have a database, that's a problem because generally you do things like store data you don't want to lose in a database. And if that storage goes away, then your data goes away. So you have to actually have a way to have persistent storage. Now, persistent volumes are the way you do that. And we'll be playing with this some today. We'll be setting up some persistent volumes. It's a resource that's provisioned by an administrator. Now, the individual containers themselves, they need a way to connect to that storage. So they send out what's called a persistent volume claim. Basically, hey, I need storage. It needs to be associated with me, and then it's assigned. And then, of course, storage class is basically the recipe for how are we going to cook this storage up? What is this storage going to look like? What do these volumes need? What size are they? And all those other details that we need to specify, that's all done with the storage class.
Yes, and that's very important because you can install Kubernetes wherever you like, any system, Red Hat, Google, but each time the storage class really depends on your environment. The storage class won't be the same on Minikube, Kind, Google, AWS. Each time this is a dedicated specification. And this is also the reason why at the beginning of the workshop, we do have to create our own storage class.
Absolutely. And I know I not so long ago was messing with a little bit of Kubernetes on AWS. And you can even tell all of the keywords I was having to use were AWS specific. So it's very, very specific to what you're actually running this stuff on. All right. Open specification. This is an overwhelming slide. Don't worry, don't panic. This is all done for you for this class.
That's
basically. Yeah. Since it's an open specification, there are a lot of different pieces that we can choose for different parts of this whole contraption. You'll notice there, the platform, there are a lot of options, and we can choose one. Now, I will point out that this makes a lot of Kubernetes deployments very unique, and you can't just pick up a container and bring it to a different deployment and say, hey, all of these things that I provisioned over here, it's going to look the same over here. If they have any different infrastructure, you actually have to set everything up for that. So all of the configs and things need to reflect what you're actually running and how you're running it. So things aren't exactly portable when it comes to Kubernetes, but the rest of the ops are all kind of taken care of for you. So a bit of a trade-off, but I think a lot of people would agree it's well worth it. Okay. All right, so Kubernetes, we're done with the workshop. We can all go home and, oh, well, probably not.
I love it. Yeah, so now, you can go and pass the Kube certification. No.
Right. Everything you needed to know. No, so Kubernetes, actually, there are a lot of public distributions out there. I think it's almost every major cloud provider at this point has some flavor that they offer. Today, if you're using a local environment, we're going to be using Kind. And Kind is actually very meta. It's let me see if I get this right. It's a Docker container that runs Kubernetes that runs Docker containers.
So, yep.
Yeah. So we're basically running Docker to run Docker. It's pretty cool. But what's actually going on, in all seriousness, if you have your laptop, that's a single box. And what we want to be playing with in Kubernetes is a lot of different resources. So essentially, what we run into is we have to create a whole bunch of little boxes out of a big box. Kind does that for us, and it's not something you'd ever run in production, right? Because why would you ever do that unless you're actually testing or developing or doing those sorts of things like we're doing today? So that's where Kind comes in. It's a great tool to simulate a large distributed environment. Okay, so as was mentioned a couple times now, you can use your laptop. I am a huge fan of doing it that way, but we also do have these cloud instances if you need them. We should be getting those handed out here.
Yeah, it's done. It's done. We are delivering the instance
Awesome.
one by one. I think we are covered. But hey, you told for most of you will use your laptop, so let's go.
Right. Yeah. No. Yeah. Absolutely. All right. So first workshop. I'm gonna hand it over here again, and we'll keep going.
Yeah. So let me do that. All right. Boom. Okay, I should have moved.
Exit stage.
Whoop, whoop. Okay, now I'm sharing my screen. All right, so let's set up your cluster. So I think we have shared 20 times the links from the GitHub repo, both on YouTube chat and Discord now, and we will keep doing that. So please, all together, let's go to github.com/datastacks-academy Kubernetes-workshop-online. Okay, and this is where I am. Just checking. Okay, so I will do the exercise with you in front of you, step by step. Let us do it quickly. So first exercise is really have your environment ready and go to set up your cluster. If we give you a Linux box, the first step to install Docker are already done. But for those of you who don't or who are using on your laptop, go to set up your cluster. And here it is. First, how to install Docker. Okay, if you are using Windows, you do have the link. Mac OS, here what you need, and in the end, you should do docker-v. This is what I do have. All right, I do have Docker ready on my laptop, so I won't go into installation Docker step, but yeah, you can go. Take your time. We do have the Linux one. Then it's all about Docker Compose. Okay, again, included in macOS, included in Apple and Linux to simply a new command to pass. Now install kubectl, which is the client to communicate to a Kubernetes cluster. kubectl, okay? So brew install kubectl if you are on Mac. Windows, there is a kubectl for Windows. You can install the MSI. To run the full workshop, you will need something like 8 gigabytes of RAM. About 8 gigabytes of RAM. And if it's going slow, at some point I will tell you maybe this is due to memory issues, but with 8 gigs you're good to go. Okay, install watch. Watch is a nice trick because we will execute some command that can take some time to run, before the cluster to be ready. It will initialize the pod. And so with watch command, you can see the pod evolving from one state to another. All right. And finally, kind. So kind is Kubernetes in Docker. This is what you said, right? Or Docker in Kubernetes in Docker.
Yeah, I saw a comment there in YouTube. It's Dockerception.
Yeah, Dockerception, something like that. So again, 3 commands to install. So I just, it's really all there. We run the workshop a couple of times, so we're pretty sure about the links. This work fine. Chocolate is a nice tool if you are running on Windows, and us on Mac and Linux are used to install something just with a command line. apt-get install, blah blah blah, brew install xyz, and in Windows you always have the MSI to download and exe file and install, and it takes forever. There is something called Chocolate, that you can install once. And then now if you want to install something, you can do choco install and what you need. And there are tons of recipes available for you, and kind is one of them. Okay, and when you set up, you can do kind get cluster and no cluster found. Okay, this is expected. For now, my Kubernetes env is empty. All right, so first thing first, let's create a kind cluster. So first command is really to instantiate our cluster, and I will, kind cluster, kind create cluster, kind Cassandra, and I will use the config setup kind config. So what I did, I have downloaded the repo, git clone or download as a zip. I do have everything running available on my laptop, and so do you. Probably just git clone the repo, and I can simply copy paste in command when I am at the root of the repo. So here, for instance, you can see that there is set up your cluster matching the path, and I can go and execute kind config. So maybe you want to know what is kind config. I can show it to you, opening a new tab. So this is simply telling kind, I want a Kubernetes cluster, what a surprise, with one control plane, the master, and 5 workers. And why do I put multiple workers? Because with the Cassandra operator we are using today, we will have 1 pod per worker. And if we want to run a 3-node cluster, let's have at least 3 workers. And if we want to do more like dashboarding, we will have even more workers for us. All right, so let's try out. I'm going to create my kind cluster with you. All right. And it's running. It should take a minute. So again, you can go to Discord and request some cloud instance. Obviously, we cannot share the cloud instance link directly on YouTube chat. This is the reason we put also Discord, but also in Discord we do have some breakout rooms where you can ask your question one-on-one.
No, I don't think I mentioned it earlier, but kind literally stands for, I believe, Kubernetes in not Discord, goodness, in Docker.
Oh, okay. Oh yeah, Kubernetes in Docker. I got you. All right. So I think if you are in the cloud box, the kind cluster is also created. I'm not 100% sure, but yeah, you can do kind get clusters and see what you get. So it's starting. Could take a minute, and so once done, I could do kind get clusters, and I should have the kind dash Cassandra cluster created for me. And you cannot hear my laptop, but now the fan just started up, and I do have a plane
like
in
you
my.
Started a heavy process or something.
Yeah. I do have kind of like a plane in my. Okay, joining worker nodes. All right.
And compared to setting up your own Kubernetes, this is actually relatively quick. I mean, if I actually had 5 servers or whatever, and I was setting this up, it would take a little bit longer. So kind is actually
and in the cloud instance, kind is already installed. Yeah. You can just go kind get clusters. And so we pick kind because in kind you can have multiple workers, and maybe you already have used Kubernetes on your laptop using Minikube, and by default with Minikube you only have a a single worker, and this is not enough. We need multiple here to do the hands-on. Okay. Again, I'm going slow in the beginning. I will speed up later once everybody will be okay. All right, so kind get cluster, I do have my clusters. Okay, then I will tell kubectl, remember the client, you will now use the cluster I've just defined when I execute my command. I'm linking kubectl with my cluster, just to be sure those are two related. And now if I start using kubectl, and we will do a lot of kubectl command, I will interact with the kind cluster we've just created. So if I, for instance, do the get nodes, you will see that I do have nodes for workers, and I do have the control plane as a master node. Okay? All right, let's move forward. We do have our cluster setup, and if you on the cloud env, maybe you already get bored because it's done for you. Okay, next we are creating a namespace. Remember, we want all the resources we created in a single namespace. It's easier to find, it's easier to filter, it's easier to delete. You know, you provide the namespace and everybody in the namespace is deleted.
Keep it all in the same bucket.
All on the same bucket. Yeah, please do it. Nice. Okay, next is, what about the storage class? I told you storage class is strongly related to the environment you are running. So there is a default one in kind, which is called standard, but we want to create our own just to define how much storage we have and how does the storage class behave. So if I go to storageclass.kind.yaml, you can see that it's more or less cloning the standard. I just make sure that the volume binding mode is wait for first customer and now to the default one, just to be sure that this volume will be mount when the customer come and ask for it. And with that, I will simply execute the command to create the storage class based on the YAML. And I will install that in the namespace. So kubectl-n for namespace and create my my storage class. And now if I execute again get storage class, I have two of them. Okay. All right, I will put that bigger just for everybody to be able to read. All right. Okay. Are we good? Tell me we are good on YouTube chat with a little hawk, on Discord with a thumb up, just to say, okay, you are all ready to move forward. Good, nice, okay. And so this is, we just did. We have created the namespace, Cass operator, and we have defined a storage class named server storage. That's it. But for now, there is nothing. And we also know that under the hood, there are 5 nodes ready to take our command and host the pod we want to run.
Sounds like we have some YAML to bake.
Okay, kind cluster can be set up for GKE instance. Well, in GKE is already a kube cluster, all right? So you will define GKE to tell I want a plane and some workers. So it's totally a competitor of kind. So it will be the same command. kubectl apply, you will apply the same YAML, but you cannot use the same storage class YAML. And this is the reason why I've provided you in the folder a storage class for Minikube and a storage class for JKE. So if you are running on JKE, so spin up your cluster to have at least 5 workers, the control plane, and to instantiate the storage class, please use the GCE PD, which is a dedicated provisioner for GKE. I told you, storage class is related to the Kubernetes implementation. Except from that, it should be fine. Same YAML, nothing to worry about. Okay, let's move into Kubernetes operators. So when a pod starts, you will create pod. So as kubectl, you will invoke the API server to create the pod. Then you will go to etcd in the control plane to store the state. Then the scheduler will start initializing one pod, and when the one is there, it will go on and communicate with the worker through the kubelet, just to be sure that the containers you ask are started. And this is important because when we will do the command, we will each time look at the state of the pods and see if they are started, blocking, initializing, and this is how you do that. You do have the pod first initialized, pod starting. So when the pod starting, we do have liveness probe telling us that your pod is starting, and when the pod is ready to get request, you will have the readiness probe telling you that it's ready. And let's pretend we will start Cassandra. Oh, what a surprise. Well, as soon as the pod is there, and you will have the liveness probe telling you, okay, the pod is there, it's starting. And only when Cassandra is ready to take request, you will have the readiness probe. All right. Okay, so that was one stuff. We keep going with the Kubernetes resources. So, when you define...
Ooh, these are important.
Yeah, so, when you define, if you are already using Kubernetes for stateless application, and this is the first use case, microservices, Spring Boot, and, all small pieces of software. Those are stateless. And so you will use something called replica set, not on the slide, replica set. And if one pod, shut down, then Kubernetes, now the state of my cluster is not matching the specification I got in the YAML, and I will start a new pod just to match the state. It's all about matching the state. So by default in Kubernetes, it's done automatically with the replica set. In a stateful set, it's not as easy. Why? Because now you are stateful. So because you are stateful, you are use something called a stateful set. When you define a stateful set, under the hood, it will create a pod, okay, no surprise, but also a volume, and attach the volume to the pod using a persistent volume claim. So storage class is a specification. I will use that to instantiate one volume called a persistent volume, and I will attach the volume to my pod using a PVC. And so, full disclosure, when we will start a Cassandra node, you will have one pod per node and a PVC per node, which is the storage for the node.
And those things are, since it's not, since it's stateful, those things are always going to be tied together from, the beginning of their life to the end of their life. Those resources will always go as a single unit.
Yeah, this is how it works. I like to say Kubernetes is an ocean of YAML, and you need to learn how to swim. And when you feel confident with the YAML, you can go hardcore and start implementing in Go, which is a development language of Kubernetes, to implement your own stuff. So, and when you start opening Go, you really are the expert now. Okay, I will go fast with the service, but service is kind of an alias. So instead of invoking something with its IP or names, I will use a service with a label. And now I would say any pod with this label running this service, with label selector, and I will act on multiple pods at a time using the service name. And so I had a question before, how do we handle seeds? How do we handle nodes? So to handle seeds, we have a dedicated service. And so this is some policy under the hood that will scale out the seeds. There is something called a headless service for that. All right, so service endpoint network policy. I can move quickly on this one. We won't really interact with those. Just know that instead of targeting one pod, we use some label and alias. Okay, now when you start a pod, you can add some config map. Okay, this is the configurations, key value like properties, and secret user password. Store as base 64, or you can also put some files in a secret. I was not aware until lately. You can totally put some files in there, and that makes sense. Where do we put some certificates if it's not in a secret, right? Yes, and yeah, so I got the question also on the chat. In a pod, you can have multiple containers. And you will see with the Cassandra, in a pod, you will have the Cassandra container and another container just to provide liveness and readiness probes. And having a container just aside another container is a pod. This is what we call a sidecar. But I will come to that later. Okay, and now the big deal. Everything that I showed to you is pre-baked in Kubernetes. But now when we define our own behavior, we need our own resources. And with the extension point is in Kubernetes is called a customer resource. So you will define something called customer resource definition and provide your specification. Okay. So this sample is specification for the cron tab. Okay. If I want to create cron tab stuff on Kube, okay, I can create my own CRD, customer resource definition. I define my spec and I simply instantiate this resource when I need to in a YAML. It will be a custom resource. I don't read all the slides. Remember, I give you the slide on the GitHub repo. Okay, and now what is an operator? Well, for anything related to existing resource in Kubernetes, in the control plane, you do have the scheduler and the controller manager that will look at the state of your pod. And I told you if the pod goes down, that the controller manager knows and asks the scheduler to start a new stuff. But now, if you have defined a CRD with your own logic, you don't want Kubernetes to act on it. You are the one who know what to do, and to define all the operations you can do, you will create something called an operator. And an operator is like a daemon watching some custom resource and listen some events coming from the custom resource and act on the custom resource. Now the operator is kind of the leader, and it will execute all the command needed to reconciliate the expected state, the specification, with the current state of Kubernetes cluster. And now operator is intelligent, it's clever. It knows that I need to start my first seed node, wait until the seed node is ready, only then I can start the new node, and so forth and so on. So this is the basic rules there is in operator, but there are a lot of rules. When to do scale out, when what is the seed node, what is not, and we will do some of those. How to scale up a cluster. All right. And with that, I think we are ready to install the operator. So in Cassandra, when you do a deployment, you can have multiple ring, so multiple nodes, multiple ring in multiple region. You can read and write from everywhere, and the Cassandra will replicate the data for you, and it's work for geographic distribution and also hybrid and multi-cloud deployment. Have you considered having the same data layer in all the clouds and also on-premise and don't have to duplicate the data? Yeah, Cassandra can do it for you, and it's not magic. You still have to do some VPC peering those nodes, from one cloud to each other must know each other using an IP, but hey, it's working. All right.
But you can achieve some crazy durability.
All right. Oh yeah. Yeah, you can lose a total data center. It's still working. Some vocabulary about Cassandra. So the full big stuff is called a cluster. Each ring is called a ring or a data center. And now you understand that why the name of the Discord channel is Fellowship of the Rings. And so some installation is a node, okay, in orange. And in Cassandra, there is some affinity. You can tell Cassandra that those two nodes live on the same rack, on the same physical location, for instance, or AZ if you are running in the cloud. And with that, Cassandra knows that when it needs to distribute the data among multiple replica, it will pay attention to avoid as much as possible having many replica in the same rack, because there is a physical dependency, and if you look the rack, you have a chance to lose multiple nodes, and this is not what we want. But the vocabulary is important to understand how we set up the operator for Cassandra. All right. So your mission, should you choose it, let's do it again. Your mission, should you choose to accept it, is to put Cassandra in Kubernetes. Okay, related to our famous TV show. All right, so the Cass operator, no surprise, is the system that will handle all the Cassandra management for you: ring initialization, seed node management, rolling reboot, store data, safe rack aware, scale ups, scale down, replace dead nodes, and it works with multi-DC cluster. It's not a single data center. We can have multiple data center, multiple rings. So how does it work? Let's see together with exercise number 2, Cass operator. All right. So I'm going into my demo mode, okay? And I will go now to my second folder, Cassandra, and I will use deploy Cassandra with Cass operator. First things to do is to install the Cassandra operator, okay? I'm using a YAML where all the definition, service account, secret, custom resource is created. So that includes the custom resource for the data center, Cassandra data center, okay? So this is all that has been created, and I can watch. Remember the watch command, the one that helps you to know what's happening? Oh, it's already down now, it's too fast, but it would have been created, initializing, and then running. So the pod, it's running now, I'm okay. All right. So as you can see, I do have some IDs when I got my pod, and this is my ID. So let me copy this ID for later command. I will open my Sublime textbook here just to copy paste. Okay. And now I will describe my pod. So describe is a command to show you what's in a pod, what's in a Kubernetes resource. So if I do describe, you can see that I do have downloaded the Cass operator. It's now running. Okay. I do have a secret attached to it, and this is all the events happen. So pulling the image, creating the container, and starting the container. All right. If I go back to slide, this is what we just created. Now in our Cass operator namespace, we have deployed the operator with some secret, some custom resource for the operator, webhook, and security stuff. But there is no Cassandra running yet. We have just installed the operator. So let's move forward. Next, we are creating a single node cluster. So it's very important to go, see the YAML file. Okay, let's see. One node. Okay. So I've opened the specification. So the custom resource name Cassandra data center. This is a new resource. We have done a custom resource definition. This is the custom resource. And in there, you define the name of the data center, the name of the cluster, and as such, you can have a cluster with multiple DC, you can have multiple clusters, and it's all based on those two properties. As you can see also, we install Cassandra OSS. We use the server storage class we just defined together, and you can override settings in the Cassandra. Okay, so here's some Cassandra YAML in the file to set up Cassandra, and you can override the property. Okay, and after talking, I will simply copy paste my request here. Okay, let me create a single node cluster like that, applying. All right. Okay, so it's created, but now I can watch what's happening here. Okay, so cluster 1, name of the cluster, DC1, name of the data center, default, name of the rack, but I didn't provide any rack in the config file, so I will use default. STS, guess what? Stateful set. So now you understand that you do have a stateful set per rack, and -0, name of the pod. So it will set up a single node cluster, and the pod is named cluster 1 DC1 default STS 0. And as you can see, I do have two probes, readiness probes and liveness probe. So here it's running, but it's still first it was initializing, now it's called running. So that means Cassandra has been starting, so I did Cassandra start, but it's not ready yet. Cassandra needs about 30 seconds, 40 seconds to start, depending on your machine. And so only when I do have 2/2 probes telling me that the pod is okay, ready to take request, that I could go and start doing some magic with it. Okay, 2/2. Now I do have my node running. And if you are doing that with me, congratulations, you have now running your first Cassandra node in Kubernetes. All right, the second command is ready to get what's in there. Just again, show the YAML file, but using a command line, but I show you on the GitHub, so that's okay. And you can also describe now the full data center, and this is what you get. Okay, you get, it is a cluster 1, you use Cassandra, and we put size equals 1. Okay, and this is all the events happening on your cluster. Okay, and again, we give you a lot of command to pass, just to list what are the pod, what are the data center, what are the stateful set, what are the service, just for you to understand what we just did. And I can show you with the slide. We have defined a YAML file like that, and this is what we have defined. By applying our YAML, we have created DC1, cluster 1 super user, which is the secret, DC1 default STS, okay, the stateful set, and that guy we were watching to start, this cluster 1 DC1 default STS 0, this is a pod. And so for this pod, a storage class has been instantiated and a persistent volume claim has been attached to this guy. Also, we have a bunch of services. So first service is all pods service. So you can act on all the pods on the DC1 by interacting with this service. There is a DC1 service to act on the resource DC, and also cluster 1 DC1 seed service. So you also have some dedicated service to handle seeds. Headless service that pods can use to contact the seeds when they bootstrap. We got a question in the beginning about that. Okay, so let's move on with the exercise. So we do have a single node cluster. That's nice. So we can go into the pod and do some SQL/SH magic. So should I do? Okay, let's do it. Let's do it. Okay. So if I want to list my secret, okay, so the secret is username, password defined for my cluster. I do have a huge password and a huge username, okay? Username, so that's operator pod, okay? All right. Oh, that's my command. I want my password stuff. Okay, so this is the encoded password, okay? And because it's a secret, it's encoded in base 64, 64. I speak French now. And so to get the proper value for the password, I will need to do echo base 64 decrypt. So I will do the command with you. Up, okay. So username, yes, it's also encoded, but it's always the same, and the username is super user. So I can also decipher the username if you wish, but it will be cluster1-super user. So I would rather only decipher the password. No, let's do it. I want to give you the time to do it as well. So our password is now that, because I've deciphered it, okay? And the cluster and the username, I can go and do that, and do that, and I should have the username, cluster1 super user. It was expected, okay? Okay. Well, so with that, let's play a little bit with our cluster, will you? Okay. I will do some bash command. I will simply contact my pod with its name and go there with the bash command, okay? And now I'm here. I can do not tool status, just to see. It's a Cassandra command telling what is the topology of my cluster. Boom, single node cluster like that. All right? Okay, moving on. I can also start the SQL/SH. And now, very important. Instead of SQL/SH localhost, I will do SQL/SH the service name. Remember the headless service? This is the name. I will SQL/SH the service name. Okay, and user and password. But guess what? The password is probably not the same, and that's expected. Okay, so my password is this one. Okay, so now let me copy my command with my proper password. And wow, we are now in the SQL/SH command. So I can start playing with all the Cassandra command, like describe key spaces. Yeah, we do have something working. Okay. 2222, describe key space. Okay. Use killer video 1. Oh yes, you can even killer video. Oh, I will create a key space. So let me, it's not there. So let me create a key space, will you?
I thought it was there. Oh no.
Yeah, it's not
there.
there.
Yeah, there it is.
Yeah, okay, so let me create my key space, DC1 replication factor 1. DC1 because the name of the custom resource is DC1, so the data center name is DC1. And replication factor 1, yay, because we do have a single node. And I can use this key space, use killer video 1. And with that, I can start creating some tables and inserting some values. And hopefully it will work like that. And I can select from my users, and I should have stuff in there. Yeah! So you and I are in the tables now, Eric.
Wonderful.
That's funny. Okay, So now let's exit this guy. Exit. I exit the pod. Now let's scale up the cluster, okay? And to scale out, let's say, add some pods. To scale out, we will edit the file. So remember, I add this file and I add, size equal 1. I can edit the file with something size equals 3. This is the only things we are changing. Now the operator will say, oh, the state that you're asking is 3, current is 2. I will add 2 nodes to your cluster, okay? And instead of editing this file, I do have the very same file here, 3 nodes, okay? And I simply change size equal 3. And if you don't trust me, I do in front of you a diff. And you can see that only size change. All right. So now let's execute this new guy and see what's happening. Okay. And I will watch. Okay. As you can see now, I have 2 new guys, STS-1, STS-2, appearing. And it will take some time for them to start up and run. And it will take, a couple of minutes maybe. We can watch all the different intermediate states in GitHub. Yeah, I've copy-pasted all the intermediate state. As you can see, it could take up to a few minutes to start. But once done, guess what? You can go back to the pod, do the node tool. Now you do have the 3 node, okay? Go back to the CQLSH command, alter the key space, because now the key space is replication factor 1, but you can totally alter the key space and put replication factor 3. And now you can describe the key space, and now the key space living on the 3 nodes, okay? And to show you that, I define consistency quorum, meaning each time I execute a request against Cassandra with the CQLSH, I want the majority of the node 2/3 to reply. And so I will execute tracing on, and in the response, I expect to have response coming from multiple nodes. Yeah, there is no other easy way to show you that now your key space has been expanded to multiple nodes. So running 2/2, 1/2. All right, running 2/2. So we change the Cassandra configuration. Okay, that was exercise. Okay, I will let the pod running, but okay. End of the exercise is really, you can not only change the size, but of course you can change any parameter in your cluster, in your node. And so the operator will do a rolling restart of your node to get the latest value. So let's see, now I do have 2 pods running. I'm writing All right, so I really want my 2 nodes. Okay, 3 minutes, almost there. I know that on the cloud instance, it's much faster. I mean, we have given you some instance like 4x extra large, something like that. Next time I will run also the workshop on the cloud instance as well. Okay, so now everything is running. So let's copy paste the few commands we just showed. So let me connect back to my pod with the bash. Okay, so to describe key spaces. We have inserting the data. We have, okay, now the cluster has been upgraded. And so I can go back to my cluster. Okay. Execute the command to login. This is the same. Oh, now I can also do not tool status first, just to show you that now we do have a 3-node cluster. All healthy. Yeah, cool. I can go to CQLSH. Okay. And I will alter my key space. Here it is. Alter my key space to have 3 nodes. All right. I will put, so now if I describe my key space, hey, I'm okay. I do have replication factor 3. It just me. I don't know how to copy paste, man.
No one does.
Oh, geez. I did a mistake in the textbooks. No, copy paste half of the command. All right, so now I will set the consistency to quorum and enable tracing just to get the full stack when I execute a command. And now when I want to select from the video, you can see that I have contacted multiple nodes. Okay, oh, there is a lot going on here, but I have 10, 2, 4, 4, 5, 3, and I have 10, 2, 4, 4, 4, 3. So 2 nodes have answered my question because I asked for forum. Okay, exit. You don't have to be so as quick as me, just I want you to show as much as possible. I can also now run the file new config. Remember, new config is a file where I have changed something. So here, let's pretend I have added a new attribute in my config, commit log sync period. And so if I apply this new YAML, I still have the 3 nodes, but as I change the config, the cluster will need a rolling restart. So I am planning, let's apply the new config, okay? And so closing this and, going to watch what's happening, which is the rolling restart. Okay, exit. This is how you scale up. This is how you, and now you want to watch what's happening. So as you can see, STS-2 is terminating, rolling restart. And so it will be start again. Yeah, I can see question in the meantime. Okay, so, okay. Look at that. Node number 3 is marked running, but stateful set, not the stateful set, but the probe, readiness probe mark it's not ready yet. So nothing happening. And only once the pod number 3 will be ready to go, that node number 2 will be terminating, no downtime. It's a proper rolling restart. Oh yeah, it's taking forever. Okay, finally, and it was instantaneous. Yeah, I almost missing. As soon as this guy was running, boom, the other was terminating. Boom, it was very fast. So if you go to slide mode, this is what we did now. We do have a data center with 3 nodes. And so we have STS0, STS1, STS2. Okay, nothing else changed. So now if I want to look inside the pod, okay, you can do the exercise under the hood, of course, and keep listening to me. There's nothing special. So first things, we told you in a pod there are multiple containers. That's true for Cassandra. Because remember, in a pod, you want to know when the pod is starting and when the pod is ready to take request. Those are two different probes, liveness, readiness. Okay, and so Cassandra alone do not allow this probe. Kubernetes expects some, HTTP endpoint to be able to invoke. And so we have created an open source, a sidecar, so management API for Cassandra. This is what it looks like. You do have a lot of endpoints available to interact with Cassandra in a REST format. So of course you do have liveness, readiness, but you have also version, lifecycle, get the status of the pod, rolling restart. You can also act on the pod through this API management, sidecar API management, and also BusyBox, which is minimal Linux distribution to initialize that stuff. Okay, so the API sidecar is also available open source on GitHub/datastack/management API for Apache Cassandra. And you know what? DataStax have implemented the operator for Cassandra. Instacluster has implemented an operator for Cassandra. Orange in France, Telecom Communication, have also implemented a Kubernetes operator for Cassandra. So you might say, oh, that's a mess. Which one should I pick? Well, that's my pleasure to announce that all three companies are working on the unique, unified, and merged operator that would be part of Cassandra 4.0. That's the plan, expecting this year. But the purpose is also to have all the bug and all the ticket closed to release the 4.0, to be sure that you can immediately go into production even if it's marked 4.0, because there are so much work in testing and fixing all the ticket before releasing this version. But just to tell you, in this Cassandra 4.0, all the community is working to have a single, or at least a custom resource definition that can match all the operator. Okay, and that way you can pick the one you want or use a unified one. So it's competition, but for the good cause. All right, so a lot of things happening. So we still have a few minutes to. So if you look at the GitHub repo, you can do much more exercise. Okay. So first is all about Cassandra. Second is about Kubernetes dashboard. Dashboard is not working in Cloud Env. There is a limitation with the security in the Linux box you can define. And so if you are on CloudBox, don't do the dashboard one. And then Prometheus Grafana. You do have your cluster running. You want to have a dashboard on top of it just to get the request. Let's try to run this guy and see what it looks like. And the materials. I told you, you do have the slide. Here they are. You do have the image. Okay, you have everything you need to do the workshop on your own later after today. So few slide dashboarding, I don't do it. Prometheus Grafana in Kubernetes are working in the same way as Cassandra. I mean, this is an advanced application. You need an operator to make it work. And as such, we will deploy the Prometheus operator, the Grafana operator, a Prometheus instance, a Grafana instance, and this is how it works. You define a service monitor in Prometheus that will monitor something. And what Prometheus will monitor, guess what? Cassandra, and for this one we will use DSC, the image of DataStax Enterprise, but it's also available for Cassandra. I didn't update the hands-on, but you can also have a YAML for Cassandra still working. But for now, we will do DataStax Enterprise, and it will, use metrics collector to export HTTP to service monitor. And I told you, we also now provide the same metric exporter for Cassandra. Simply need to update my YAML to deploy not DSC but Cassandra pod. Okay, so let's see and go hands-on mode. So Prometheus Grafana, first things to do is to stop the existing 3-node cluster we have. And to do that, I will deploy a new YAML file. And the only thing that changed is I do have not this one. I do have a property in the YAML called stopped. So how do you stop the full data center in Cassandra without deleting? Simply just update the YAML providing stop equals true. So if I apply this guy, it will simply stop my cluster, and I can see that it's quite fast. So now I do have 3 running. Okay, the pods terminating properly. Okay, and once they will be terminated, they will just disappear. And yeah, that's not enough. I will also totally delete the full DC to start with a fresh start to do the Prometheus one. Okay, and 10 minutes would be enough to have something running, I guess. Yeah, it still needs to start up. Okay, right. Now I still have my data center with no pods. Funny, right? Operator is still running. Okay, let me delete the resource DC1 because it's still there. Okay, now DC1 has been also deleted. All right. So now let's install Prometheus. Alors, OLM means Lifecycle Manager, and it's required to work with the custom resource definition of operators. Okay, so operator is deploying. Okay. All right, waiting, installing. As you can see, it's all copy paste. Okay, I hope that it's boring. What? It's boring? Who say that? Okay, so once I've do the lifecycle management, I will do my install my Prometheus. Okay. Wait a bit for the group to be created. Yeah, I'm not sure, Kavi, if you're doing the exercise, because man, that's a lot to do in 2 hours, I will tell you. Okay, operator is installed. Okay, let's do instance. Okay, that's expected, already exists because we try to create again the group. Okay, that's fine. Or did I copy? No, I didn't copy. Sometime, okay, let's copy the proper. If it's already exists, okay, this one was already existed. I know it was something, it's not a big deal. It's still starting. Okay, let's do it. All right. So is it still creating that stuff? Yeah. It could take a bit of time to...
Yeah, we might be cutting it a bit close, but we'll be all right.
That's funny. Anyway, you can still do the command on your own. Just think what this guy is still in error. Oh, that should be totally fine. Okay. It took a bunch of time for the operator to start, then to be able to install the instance, and then finally the service operator. Okay, we're good to go. Now let's go for Grafana. Okay. Now let's connect Grafana to Prometheus. Well, that's some command to pass. Okay. And now the dashboard. I'm sure I will have to do the dashboard again, but never mind. Okay, boom, 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 boom. Okay, and now finally Grafana instance. That's a lot to install, you know, OLM, Prometheus operator, Prometheus service monitor, instance, then Grafana instance, Grafana operator, Grafana dashboard, connect Grafana to Kube. And, you know, I told you, an ocean of YAML. All right, and so with all that, I do have a tons of things running now in my... Boom. There is a lot running in there. So multiple operator, okay? And Grafana, Prometheus, and Cassandra. Okay. So now let's enable port mapping for Grafana. Ah, it's still not running. Oh man. Okay, so during the initializing files, I will also start my DataStax cluster. So DSC mini, okay. Now I will directly go to the full stuff. DSC mini matrix enable. This is the one I want to run. And so if I go to this file locally, so DataStax, workspace, Kubernetes workshop, DSC mini enable matrix. You know what? I will go there and edit and just put the size to 1, okay? Just for the cluster to start faster. All right, let's go. And yeah, it will start, everything will start at its own pace. And to enable metrics, I simply have to provide 10 write POM here. Okay. And so I will let that start, and maybe we should do some stuff. Okay, where is my command to? Okay, port forwarding if I need to. All right, thank you very much all for your time. If you like the content, subscribe, leave us some feedbacks on Discord, on YouTube chat, and until then, see you next week. Thank you very much.
Thank you all.
Bye.